All right, I'm going to give you... Okay, press pause while you work on this one. All right, we're going to pretend for a moment that instead of having this inside function, we have just x. So then to find the derivative of h of x, we take our outside function tangent of x, and we differentiate it. The derivative of tangent of x is secant squared of x. Okay? But we don't have the tangent of x, so we're not going to have the secant squared of x. We have the tangent of e to the x plus 84x. So instead of having secant squared of x, we're going to have secant squared of e to the x plus 84x. All right, so now this is the derivative of the outside function, which the derivative of tangent is secant squared, evaluated at the inside function. So instead of having x there, we're going to have the e to the x plus 84x. And we're going to take this and multiply it by the derivative of the inside function. The derivative of e to the x is e to the x. The derivative of 84x is 84. So I'm just going to clean this up and bring the e to the x plus 84 out front. So we have e to the x plus 84 times the secant squared of e to the x plus 84x. Okay, here's a slightly different example. We still have a composition of two functions, but I'm going to go ahead and have you work on this before we do it together. Okay, press pause for a moment and work on it. Okay, as always, our first step is to figure out what the inside function is. And when you have an exponential function, the inside function is going to be whatever you're putting into the exponent. So we imagine for a moment that rather than having e to the x cubed plus cosecant of x, we have e raised to the x power. So then to differentiate this, we're going to differentiate e raised to the x, but then instead of having the x there, we're going to have an x cubed plus cosecant of x. So the derivative of e to the x is just e to the x. So instead of having the x there, we're going to have our inside function there. So it's going to be e raised to the x cubed plus cosecant of x, then times the derivative of x cubed plus cosecant of x. So it's going to be 3x squared plus the derivative of cosecant of x is negative cosecant of x, cotangent of x. So then I'll put this out front. We get 3x squared minus cosecant of x, cotangent of x, times e raised to the x cubed plus the cosecant of x. Okay, I'm going to give you one last to try on your own. Okay, so work on this one. All right, again, our inside function is going to be the exponent of e. So we pretend that that's 3, instead of being 3e to the root x plus 2x, we're going to pretend that it's 3e to the x. When we differentiate 3e to the x, we get 3e to the x. So h prime of x, we would have, if this were x, we would have 3e to the x as our answer. But we don't have x, it's root x plus 2x. So we have 3e to the root x plus 2x times the derivative of root x plus 2x. Root x, that's really x to the 1/2. So we have 1/2 x to the negative 1/2 plus the derivative of 2x, so plus 2. So here we get 2, or I can do 1 over 2 root x plus 2 times, I'll put the 3 out front here, times e raised to the root x plus 2x. So that's our derivative there. Okay, so here's the formal statement of the chain rule. So it says if you want to differentiate f of g of x, it's equal to f prime of g of x times g prime of x. So this right here is what f prime of g of x, f is the outside, and g is the inside. So f prime of g means the derivative of the outside evaluated at the inside. Times g prime of x, so that's the derivative of the inside. Okay, so that right there is the chain rule.